Thank you. Morning. How are we? Doing well? Awesome. So this is things that every JavaScript developer should know. Before I start talking about those things, how many people are in this room? Literally everybody is going to have a different opinion about what every JavaScript developer should know. So there will inevitably be 100 evals going, oh, you didn't put this in. Why did you put that in? Well, because these are just things that I have run across, that I have seen that JavaScript developers should probably know. In 40 minutes, is this going to be every single thing? Possibly not. Or for every single scenario? Possibly not. So there are some advanced things, but there's also basic things. Sometimes people say, well, that was a very basic thing you talked about. Yeah, if you don't know that, why are you developing JavaScript? Like, seriously, right? So we'll start with some very basic things, such as, did you know? There are people who do not know that Java, and I'm not kidding, Java and JavaScript are different, right? Right? Java people are like, I hate you. That's okay. I'm a .NET person as well, so I'm used to that from the Java crowd. So here's another one that you should probably know. Right? JSON is JavaScript object notation. Yet, yes, there is a professor at a prestigious university in the UK, I shall not name it, that calls it Java object notation. It is not. Right? So I tweeted this one day. And here's the responses I got. What? Yes, it does. That's why it's called that, right? Yeah, yes, it has everything to do with JavaScript. That was kind of the point, right? I mean, granted, we could use it everywhere else, but that's where it came from. But the even more interesting response is this bottom one. Are you, what? What? But did it come from Java? I think you didn't read my tweet now, did you? That was kind of the point of my tweet. So, FYI, folks, Java and JavaScript are not the same. Let's start with that one, right? If you don't have that down, step away from the computer for a few minutes and figure it out. So it isn't. I like to say Java is to JavaScript as ham is to hamster. Granted, both ham and hamsters are tasty, but they are not the same thing. So it is not. And JSON is JavaScript object notation, even though you could use it in Java. So let's start with a little bit more basic. Data types. A lot of people say JavaScript is a typeless language. It's not. There are types. You have primitives or value types, right? Like your numbers and strings and stuff like that. Null, undefined, our favorite, right? And then you have your object types, object and array, right? So you have those. Boolean's also a primitive or a value type. The thing about JavaScript is that it doesn't care about the types. So it's not typeless, it just doesn't give a hoot. That's basically it. It will let you define a variable with no type at all, or a type, and then let you change it to some other type. That should probably not happen. So you could cram anything in a variable. And this has been an issue for developers for a long time, right? Since about 1995 when JavaScript came out. And when it came out, by the way, way back when, that's like, what, 30 years ago or so? They actually called it JavaScript just to confuse people into thinking it was like Java. Hey, it's still working, apparently 30 years later. Right? So there's our data types. Now, there's some new data types that we might want to know about as well, such as a symbol data type. So let's take a look at that. Also, some of the other cool things that we have in here. And let me up my fonts on here. They keep kind of resetting themselves. Let's see. So if you haven't seen this new symbol type, this is pretty cool. So, sure can. I was wondering which theme might go better, and I switched back and forth a few times last night. Is this a little bit better for everybody? Yeah, okay. Everybody seems into the dark theme, and I really don't like it myself, but I put it on because I think that more people like it. But yes, I'm not the only old person with glasses here. So, okay, so without symbols, you know, you might do something like this, just, you know, plain old code and some functions. And what is the symbol anyway, that it can help us with this? Well, symbol allows us to work with like key value type of pairs or dictionary, which JavaScript actually holds everything under the hood as a dictionary. Everything does have some sort of identifier to it, and then the data. So like even a function would have some identifier. If you give it a name, it's that. If not, it makes up something. And then it has the data, which would be the function, or if it's a variable, just the value, etc. So here, if I were to create something, wonderful naming here as a developer map, and I meant to change that to something else, but whatever your variable is. So I'm going to make this little object here, just a blank object, and then a couple of symbol types. And when I do that, I do symbol, and in parens, some nice friendly string, like greeting and programmer greeting. So those symbols are stuck into here. And then when I go ahead and use array notation on that object, I can then put that symbol in as the key. And then I can even refer to it later, like you would, like key value pair. So that's very handy. Of course, we could work straight up with arrays, but then you have just, you know, numeric indices to work with. But this gives me a way to have a nice string identifier for the indice as well, if I want to do that. So that's a type that came out with ES6, 5 or 6, somewhere around there. It's a later type, so it makes things pretty handy. And a lot of folks missed that one, right? But it's one of the newer types. Of the few types that we have, right, which is value, reference. Also, with our types, if you come from Java or .NET or many languages, you might be familiar with the stack and the heap. JavaScript does a similar thing to other languages. It actually uses garbage collection. You don't manage memory like you would in a C-based language. It does that. It allocates memory, deallocates memory. Not always so great, but it does. And it does that on the stack or the heap. So those few value types that we have, number, string, boolean, null, undefined, object, and symbol, they all just go on the stack, and they just stack up nicely. And then the reference types go on the heap. So you technically do have that little pointer to it, right? So the same thing happens there as it does, or the same conceptual thing. The way that it works with garbage collection might be a little different than some of the other languages, though. This kind of ties in nicely with scope in functions. So functions are objects, right? And they're just key value dictionaries under the hood. But they're callable objects. And they're callable in so many different ways. Right? You have a function statement, you have function expressions. Later on, we've introduced arrow functions. And with each way of working with functions, you have a little bit different way that it works with variables. And depending on, when you get into some of the later versions of like ES6 or even ES5 and beyond, depending on if you're doing a var still or a let. And some of us get to do some of the new modern JavaScript all the time. Maybe you're working with Vue or one of the more modern frameworks, but maybe you're not. Anybody stuck with this old, terrible, like legacy code base that's been around for a while, and then everything's varred everywhere. Yeah, I know, right? It's horrible existence, isn't it? I feel you. Yeah, so you have that maintenance code and you're stuck with it. So when you have to do things, you might have to do things old school sometimes. So that makes it a little bit more difficult, right? ES5, ES6, and later on TypeScript and some other languages as well, or super types of JavaScript, came out to help us manage some of these issues, especially around, say, functions and scope. So for functions, let's see, all different kind of functions, right? So if I just want to work with regular functions, we're used to stuff like this, right? Just using a function, the keyword function, declaring a function, and doing stuff, right? And then those functions can call other functions. When I call that other function, it puts those local variables of value type on the stack. And then again, if it's an object, it puts it on the heap. So the functions themselves go on the heap, but their values go on the stack. But I might do something like this, right, and use a function expression. And then what does JavaScript do for these? If it's a function statement, which is just your plain old, like everyday, any old language kind of function, it hoists that up to the top, right, with any floating variables, right? That you'll have that one person on the team that goes, crap, I can't get to this I'm just going to stick it outside of all the code, and then it's out there in the global scope. You know who that person is. There's that one person on the team who does that. If there isn't anyone on your team who does that, is it you? It's just asking. So there is somebody always does that. So what happens is, same thing with functions, right? If it's a statement, it just gets hoisted up. The expressions and arrows just get run in line, right? So they get to sit there. So if I were to do things like, I could call these at any time, right? And it's not going to complain when I go to run this. If I try to call this before it's declared, JavaScript's going to yell about that, or the parser is going to yell, really. Then we have arrow functions a little bit later, which gives us a lot of cool ways to be able to work with things. For example, instead of actually, typing, we're programmers, we sit at a keyboard all day, but we do not want to touch it. Makes all the sense. Actually, I like to say this about programming. Programming is like golf, right? The point of golf is to play the least amount of golf, right? It is, right? The least amount of, right? The point of programming is to write the least amount of code to get the job done, right? So it's a lot like golf in that respect. Unless you are a consultant who is paid by the line, right? there's every once in a while somebody gets that job. Oh, yeah. Good for that person, not good for anyone else. So here, maybe I have a little structure here of an array, and I just need to quick loop through that. Well, I could do that. Instead of setting up a whole function, loop through the elements, print them out. One line here. I could just reference the elements, call for each, and then log them out to the console. So that makes that pretty easy. Right? Or things like multiplying, a classic function, just to multiply something by 2. Right? So here I would have multiple lines of code. That's at least 5 lines of code. That's so much code. That's terrible. But here, just 1 line of code, right? So we could reduce that. Of course, on the flip side, you could get somebody who writes like this one gigantic arrow function that makes it worse than all the rest. But this is a great way to be able to deal with some code. And also, in JavaScript, it's very dynamic. Right? And I think this is where people mix up, types versus not. It's dynamic, right? So I can do things like this, and I don't need to go and name everything. JavaScript will accept things without a name, right? So I can have arrow functions and anonymous functions. which is really nice. With these comes the concept of closures, which is something we definitely all need to know about. Now, closure, and there's a lot of arguing about what closures are, but generally, in JavaScript, if you have a function or a block of code, and inside of it you have another block, and inside of the inner block you have something declared, that can get to stuff outside of its block that may not specifically be declared or looking like it's declared for that. So anytime we create something like that, where the inner parts can see the outer parts, we have a closure. So something like, we might have a scenario like this, where I'm declaring a function called f, and I'm just using an arrow here. And I'm working with that, and then I decide, you know, I'm going to be that person, and I'm going to put the variable outside. Right? Yes, I'm that person on the team today. Okay, well, I could see it in here, yes. I could see it in all of the functions that are within the scope of this, right? Which at this point is, since it's just in some script, it's out at the global scope. It'll work, probably most of the time, but this is rife with problems, right? Anywhere could change this variable I to something, and if it does, when I get to this line of code, it's going to be not what I expected, right? So it's very easy to change that. Also, like outside, I can see it too when I go and I run this function. So that causes what's called the side effect in programming, right? So instead of just passing all the data into the function and working with that data inside the function where it is not affected by the outside, so you get your own little community, you know, your own little thing, kind of like the Amish folks in the US. They're their own little community. They stay there. They don't talk to other people. That's a pure function, right? And functional programming works a lot this way. So it decreases side effects. Also helps you manage state and data a little differently. But what if somebody wanted to do something like this? And I had to comment this out because it will error. So if I uncomment it. All right, so, well, what if I needed to take that same function, but I wanted to wrap it in a block? So just if true is fine, any block is fine. It's just the block part that we want. Well, what's going to happen? Well, then it's going to get upset about things when I get to here. All right, so I won't be able to run some of that. So I will comment that back. But what if we change it around? And if you look at this function declaration here really quick, it's inside of the if block. So what if we change it around and I still need that block, but then I could just kind of do the same thing but with the function instead of the variable? Well, now it's going to be a little different, right? Because I've declared F3 outside. So then if it's true, it's going to be, I is going to be available in here and we're going to be good. If I go through and look at this, it should give me the whole contents of the function and everything. All right, so closures help us deal with variables that way, as does let versus var. So if I had a var before, I open up something with a var. And in this case, I have more closures, right? Because I have a function and a for in here, right? So I have blocks inside of blocks. So if I have, say, a for loop with a var, what's going to happen if I run this, right? It's going to print out a little bit of data. Then we want it to print out loop done, right? And I won't say what it's going to print out just yet. I'll run it in a second. But then I have something very similar. I have this second function, all right? So what if I'm looping and I need to do something like run a set timeout or maybe make an AJAX call or something asynchronous in here? Probably right away you're thinking, oh, that's going to mess stuff up, right? Just because asynchronicity to start with. Of course it does. That's why we added in here. So some odd things can happen when we run this. If we squeeze a little set timeout or some other code in here, even though I'm looping. And also, if I change this from let to var, we're going to see some different results as well. So before I run this, and then show that the loop has been done. And then if I come down here and change it again, right, and I'll leave it as let, but just have it run with the set timeout, right? Let's take a look at some of these results. Let's grab my tools really quick here. Nothing prints out. Oh, whoops, I have to click the buttons. Right, so 0, 1, 2, loop done. Yeah, okay, that was a standard loop, that first one, right? So there's nothing out of line there, nothing weird. If I come down to the second one, so this is our loop, right, 0 to 3, or less than 3 actually, right? So it should say 0, 1, 2, but we have a set timeout in there. Oh, that's not what we wanted, right? So can we see what that's doing? Right. Actually, oh, there it bent. It wasn't bending before. Okay. So that's not what we wanted, right? So the loop is, it prints that first, and then 3, and if I look over at the other side, this, yep. Let's see, I should have a utility to zoom in here somewhere. Yep. Right, so I have 3, and then also it shows me that I have 3 of them. Right, so it printed out 3. It actually went to print out 0, 1, 2, 3 3 times. That is way off, right? So what's it doing here with this var again? So what it's doing is, because of the set timeout, it's able to whip through this, but get to here first, all right? Which, if you're running stuff asynchronously, you can run into this problem, right? Because it's not deterministic. But then var is creating a new variable each time it's going through that loop. So then that's why I'm getting 3 of 3, right? So it's doing 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So it's doing that. So when I have var in here, that's causing that kind of issue. So when I come down to the third one, and I change it to a let, and I run that third one, there we go. So I get 0, 1, and 2 in there. All right, so that's a little bit better. At least it's looping correctly, although the loop done does show up first, right, because of the set timeout. So again, that could be something non-deterministic like an AJAX call. So when we're using var versus let, and we're thinking about functions and how to work with them, we have to remember that there's going to be closures created, and we want to, depending on what you want to do, you probably want to trap variables right in their scope, right in the block. So if you do stuff with lets, which is the, was it ES5 or ES6? I can never remember which came out in which ECMAScript version. So if I do lets, I'm going to get pretty solid results. If you do vars, which are a more classic way of working with JavaScript that you'll see in legacy code bases all over, you might not get predictable results. The thing is, though, you will see this in a lot of legacy code bases. And then often you'll see little coding workarounds for that are sometimes even comical, the way people have to kind of deal with working around those things. So closures and scope are kind of interesting, and we do have to keep them in mind. It's very important to know that when we have those variables, we probably want to trap them in a certain scope, right? Be it the block or the function. Every once in a while you might need a global, but we try to avoid those, right? Because those cause so many side effects and problems, right? And they tend to be able to get lost, right? So with that, of course, global, right? So we know if I had one JS file or multiple JS files and one HTML file, and I'm pulling them in with the script tag, or if I'm pulling them into other JavaScripts with an import, right? Either way, you're going to get pollution, what's called pollution, right? So you're going to have this variable hanging around, possibly stomping on other variables, right? So that's also part of scope as well. So we, again, try to generally avoid globals. So here, if I had a small HTML page with just a button to see who is who and an output, this is really simple code, right? So if I just simply put in, there's a whole bunch of Rachel developers I know. It's really weird, right? Must be like the popular lady name for developers. And then I change this variable. Now we would expect this to change it. It's right in the same scope. I see what's going on here. Yeah, that's great, and that's in this file. But what if I'm unaware of this other file? And I've even made another var here, right? Or this third file, right? Whether or not I've redeclared it with var, right? It's just going to keep wiping out each other because they're all in the global scope. And if I'm unaware of those other files and other assignments of this variable somewhere, it's going to be overwritten, right? So because in this case, I didn't declare any of these anywhere except just out into the global scope, which is usually at the window. So we don't want to do stuff like that. So when I run this, it's just going to give me the last one, right? Because out in the console, I suppose. So it ends up printing them all out because I print them all out in each one. But you see the last one ends up overwriting what the rest of them would be, right? But I did a console.log to all of them. But you could see that last one, right? That's what that variable is. So watch where you put your variables and carefully think about like the scoping issues and when you're creating a closure. I'll show you another closure later that's kind of interesting as well, how you can work with closures and this. So var versus let. Var is generally considered function scoped, but you can declare it globally as well, as you've just seen. Let is a little bit more controllable. Block scope behaves a little bit more like other languages. It's interesting in that we've had JavaScript for a long time, and folks complained and they said, it does this and it does that and it lets you do too many things, and then now we end up making it look a little bit more like other languages, and then we say, oh, yeah, it looks a lot like other languages now. Developers like to do that. So our closure, again, is just an object that combines the function and the environment. That's our textbook definition of our closure. So the environment and the function that you have in it. And generally, JavaScript does what's called the lexical scope, right? So if I had those variables inside of a loop or a variable outside of a scope, the stuff inside the block can see it. So we saw that. As far as arrow functions, back to those again. Just something to note on them is that they don't create their own value for this. And I'm going to show you a little bit more on this in a second. But generally, this in other languages refers to the currently executing instance of some object. But this in JavaScript does not. It could mean a lot of things. It could change when you're kind of not looking. So this is generally going to be something that's currently executing, but if you pass this into something else, it could change. And you might have seen this with a common pattern, especially in legacy code, where somebody will do a var self equal this, or a var that equal this, and then trap this, and then let this kind of carry on and change, but they've already trapped it into some other variable called self or that or something else for a while. So if we are using that legacy code and then you move over and start using arrow functions, you might not have noticed that it doesn't create its own value for this, and you're expecting this to behave like it traditionally did, and it might change a little bit on you. Inheritance is also something to know. Inheritance and properties in JavaScript. So inheritance and just object-oriented programming, which you can do in JavaScript. It's multi-paradigm. So it's OOP, it's functional, it's dynamic, it's also procedural, it's many things. It's like a stew, right? Or a gumbo of programming. You can do anything. It is Wild West. So inheritance, instead of your standard inheritance, you still get inheritance, but it's prototype based. And prototype is just this other object that is a link to another object, right? Somewhat like a pointer. Behind the scenes, it does use pointers at some point, but they have this little prototype, which is just a linker for various objects to link them to another and to what they're inherited from. In earlier days, you would create a function and you would actually use this prototype syntax. You'd say like object.prototype or even object.defineProperty to define a property. But then along came ES6 and they threw in a class keyword, which made it syntactically nice and pretty. Also a little bit easier, right, for you to work with object-oriented code. So we have that available now, which is quite nice. All right, so if I look at, say, some classes in here, now in ES6 you could do something like this. Right? I could just say class vehicle. I can use the word constructor and actually create a constructor. So that will run whenever somebody creates a new instance of that vehicle. Then I could even, here make some and pass in data to the constructor. I can even inherit by saying, class car extends vehicle, and even calling up into that vehicle, right, one up the chain. Now, behind the scenes, JavaScript's going to make those prototypes, which are just links from car to vehicle. If you've ever gone into tools and you look around, often if you poke around in your console or in the debugger, you'll see when it prints out objects, and you'll see this prototype, and that's kind of what you're looking at in that case. Right, so classes are really nice that you could do that in JavaScript now. Also, I think I should have somewhere a sample in here with some of the defined properties as well. Oh, here it is. Right. So here I could have another class. And you can even have, now in that first class, if I look here, this is a little bit more Java-ish, right? So I have a class vehicle, but I actually just have two functions. They're not actual properties, right? It just says get name and get type. If I want a property, I can actually have like a getter and a setter in here. So I could do something like this and actually use the get key name, right? So get name, set name, right? And then person can walk, right? So I could do stuff like that. So that would just print out Bob, right? So nice thing there with that. For properties as well, right? So here I see more properties, get and set. And whenever I use properties like this, it enforces an object-oriented principle called encapsulation. So if I have this product, I can then do something like this. Discount. All right, if I want to allow somebody to code a discount, well, I could come in here and check to see that the maximum discount is 80%. All right, so I make sure it goes up to maybe 80. If it's up anywhere between 0 and 80, I'm going to go ahead and assign that value. Otherwise, we're just resetting it to 80. We're not going to let you go further. So if I run this code here at the bottom, and I look in the console, I'm just going to see that it just goes right up to 80. Right, when I buy that. So if I look at those objects in here, and there's that prototype as well, right? So I could see the links in here. But you see, I set it to 80, and then I tried to set it to 99. It just reset it, right? So I can enforce business rules that way and enforce encapsulation. Alternatively, a slightly older way of doing it, you might have seen stuff like this, right? In older JavaScript. So if you're maintaining code, you would see, some local variables, right? And then, a function get name to return the name, the function set name to return the name. So it's a lot of extra code than maybe just using a getter and setter. We later moved on to doing things like define property if I wanted to enforce those business rules. So in legacy code, you'll probably see a lot of this. If you use TypeScript and you build classes with getters and setters, it actually does this behind the scenes when it generates the code. Depending on your target, right? Some of the newer targets you might see a little bit different, but it does definitely generate these at some point. Right? So inheritance is a good one. Let's see. Arrays also are kind of interesting. So let's see. Arrays. They aren't real arrays per se, because you could do things like, if I do these 3 arrays, right? I have this new array, regular array, and a new array with a cap on it. And then I go ahead and I run this, right? And I push something to the first one. Gives me the length and is it an array and what it's about. Do the same thing for the second one. They're going to be the same. But that third array, if I push something, you're going to see some weird and different things than you would expect. All right, so if I run in here and then immediately accidentally close it, that's what we do. All right, so that's what I expected. It's just 1 2-string. Right, that's what I expected. Let's get to that third one. Right? Wait, what? Right, so I told it to go to 5, length of 5, and then I pushed on it, and it just said 6. And then when I printed it out, here's what I got. So it just had a bunch of empty stuff, and then put something on the end. So often people might not be expecting that kind of behavior. If there's nothing in the array, you might expect something like undefined, which is what you'll get if you use a regular array syntax. And I try to get something that has no value in there. But if I do it with the new array, right, I might get a little bit different behavior. Right. Also, when you use the new array syntax, it adds like a little extra wrapper, and some folks have found performance to be a little bit lacking in that case. Something that we come across pretty quickly, and it's often painful for new developers, operators. We have this notion of truthy and falsy in these 2 different type of operators, right? The abstract and strict equalities. When you have them, they have these different truthy and falsy values to them. So truthy values are like anything that's not a hard false, a hard 0, and then also, like, why is an empty string falsy? Null, undefined, and nan, right? It's like these things are true, sort of true, maybe. We don't know how's JavaScript feeling today. Right? That's kind of what they're like. So this gives us some interesting results. If I run some code here, and all that this does is it creates a table and compares all those things. Like, does false equal 0? Shouldn't. What do these equal, right? So we'll just take a look at this table. It's just a table that prints out all these things. All right, so, all right, if I do these abstract, look at this. That is not true. You're lying, JavaScript. It's just not true. This is also not true. JavaScript says it is, though, right? If I do the abstract or the double equals, right? If I do the strict comparisons, boom, false. Now, that's what other languages do, the stuff on the bottom, right? But JavaScript's like, I'll let you have this one. That's not what I want in a language. You can't compare these for a good reason. JavaScript does not agree. And the reason is, like, it'll go and try to convert those values, right? So one of these is an actual Boolean, like false. And the other one's a string, 0 in a string. So they're not the same by definition because they're different types. Different types can't be compared. But JavaScript goes, oh yeah, I could do that anyway. I wish it wouldn't. Well, we do have the easy way of dealing with this, and it's just always using the strict comparison. But it does give you some weird results sometimes if you don't use a strict comparison. All right, so that's something. It's bad enough that somebody had to put this out on GitHub. like an actual table for equality. If you just use the strict equality, then you're good, right? For this, I'll quickly show you this thing, right? I love that little tweet. It's hilarious. Something that might happen with this, right? So I have a list, an unordered list. And amongst this HTML, I have a button, right? And when I click the button, it's going to loop through that list. And what's going to happen is this will change, and that's because of the closure that we talked about before. So when I click this button, the button is this, right? And as it loops through, it's going to turn whatever this is to red, right? So it goes through, there's this, and then I'm doing the pattern of var that equal this, and then I'm just printing it out in the span. And then the same thing, I'm looping through the function, and then this time I'm using jQuery. So this is a much older sample. And I'm eaching through it, but this would work with any closure that you create on the inside here. And as I go through, it's actually going to change this to what's inside of that loop, or what's inside of each list item. Right, so if I run this and click the button, right, you'll see, yes, it did see that the button is this. And it also sees that each item is this as well. All right, so we have all of the thises. And then the last little piece here, this is actually legit code. All right. Because of the dynamic nature of JavaScript, if I create a function with no args, I can actually do this. I could call it with whatever I want, and it won't error. Like any other language would be like, hey, stop that. That's nonsense. Not JavaScript. JavaScript is like, yes, nonsense. So wait, what? Yes. So what it does is it just creates the first one. It makes the first item an optional argument, which also, this kind of bothers me because I'm used to optional arguments at the end, right? That's just a little pet peeve. But here, if I have, say, this function, one argument, right? And all this does is print out a little thing. Yeah? Yes. Sorry. But here, when I click this button, if I just call it with two arguments, it's going to pick up that first one, right? And it's going to ignore the second one. But if I call it and I throw this call in here, also bind or apply, and I pass in two arguments, the first one turns into this. Oh, there's this being that thing again, right? No, I don't want edge, sorry. Right? So when I run that code, first one, it just doesn't, it's like, what? So it just calls it the window. But then it actually, this is each one of the first arguments that I passed in. Right? So another way that this can change on you depending on how it is applied.
Rachel,
Yep,
sorry.
I know. Yep. Oh, a good thing. I talked about garbage collection before. I just had it on the extra slide. Just that was it.
You could propose the open space topic and finish this up.
And now I'm being thrown out. So
sorry.
Thanks. Sorry for going over.